Today, a tornado tore through the Union City area in Michigan, and the sky left almost no time to breathe.
Warnings are polygons, but damage is personal. Roofs were peeled back, trees were ripped out, and a community was forced into seconds.
Reports say 4 people died in Michigan, including 3 near Union City, and more than a dozen were injured.
The National Weather Service confirmed a tornado,
But the final rating takes time, because science measures scars. So what is a tornado, really? And why can it appear like a sudden decision by the sky?
it's a case file, Union City Today, and the hidden logic of tornadoes. This episode's educational. In real storms, follow official alerts. To understand today, we start with ingredients.
Tornadoes are not random. They are built from physics.
Ingredient 1 is instability, warm, moist air that wants to rise. Ingredient 2 is wind shear, winds that change with altitude. Shear often creates rotation lying sideways before any storm ever spins. An updraft can tilt that rotation upright. Now you have a rotating updraft, the engine of many tornado-producing storms.
The classic tornado machine is the supercell, a storm with a persistent rotating updraft. On radar, this can appear as a hook-like signature, often a warning sign. But rotation alone isn't enough. The storm must tighten it near the ground. Downdrafts can help concentrate spin, like twisting a wide ribbon into a cord.
Sometimes a funnel forms and never becomes a tornado. Other times it touches down, fast.
A tornado is officially a tornado when the circulation reaches the ground.
And not all tornadoes come from supercells. Lines of storms can spawn fast, hard-to-see tornadoes too. These can form quickly, giving less time to react. Today's system moved fast, and multiple areas reported severe impacts.
Michigan sits where air masses often clash, especially when warmth surges north.
Michigan averages far fewer tornadoes than Tornado Alley, but fewer does not mean none.
And today, one of those rare intersections landed near Union City.
For people on the ground, tornado days often feel like the atmosphere is changing its mind.
Under a rotating storm, the base can lower into a wall cloud, an early sign of organization. Funnels can hide inside rain, making danger nearly invisible.
Radar can sometimes detect debris, confirming a tornado is on the ground.
Warnings reach people through sirens, phones, and broadcasts.
Tornado damage is uneven. One house can be destroyed while another stands nearby.
That's because the violent core can be narrow, cutting a thin corridor.
The wind is only half the danger. Flying debris does the rest.
Uprooted trees show how much force can be applied in seconds. Tornadoes can leave surreal contrasts.
destruction beside untouched objects. After the vortex passes, the event becomes rescue, medicine, and logistics. Officials reported 3 deaths and at least 12 injuries near Union City.
When tornadoes hit, response becomes a second system: coordination under pressure.
Today's outbreak included another fatality elsewhere in southern Michigan.
A tornado isn't just a point, it's a path through time.
Now comes the scientific step: measuring what happened. Tornado ratings are based on damage indicators, not direct wind measurements. So early headlines are emotional. The official story is slower and more precise.
The enhanced Fujita scale estimates wind from observed damage. But damage depends on construction quality, anchoring, and debris.
So 2 homes can tell 2 different wind stories.
One viral clip cannot tell you the wind speed.
Scientists use many indicators across a path to estimate intensity. Modern surveys use drones, GPS mapping, and high-resolution imagery. Radar sees rotation in the air. Damage surveys reveal what reached the ground.
And here is a core mystery. We can see rotation, but the birth moment is still hard to predict.
Why one storm produces a weak tornado and another produces a strong one is still a frontier.
Some tornadoes intensify extremely fast, leaving little time even with warnings.
Some tornadoes contain multiple vortices, creating pockets of extreme damage.
Pressure changes and turbulent gusts add to the chaotic forces. Damage can be amplified by debris impacts, not just wind pressure. Tornado paths can wobble, widen, narrow, and shift unexpectedly.
Warning lead time varies, and sometimes it isn't enough.
In real life, safety is about simple decisions made early. And that is why tornado science is also human systems science. Union City today becomes a case study of physics colliding with community. But this was not the first tornado story in history. So we compare the past to understand what is still mysterious. History holds extreme tornadoes, reminders of how powerful these systems can become. Modern disasters taught hard lessons about warning response and community resilience. Union City is a reminder that risk zones have edges, not walls. When warm moisture meets strong upper winds, the ingredients can align even far north. Storm seasons shift and vary, and scientists track patterns carefully. But trend claims require careful data, not viral intuition. In weather, uncertainty is honest. What we can say today: a confirmed tornado hit near Union City with fatal consequences.
What we cannot rush: the final intensity rating and full track details.
And now the mysteries. Why tornadoes are still one of forecasting's hardest problems.
Mystery 1. Many storms rotate. Few create a ground-touching tornado.
Mystery 2. Why do some tornadoes strengthen in minutes?
Mystery 3. Why do paths wobble and shift so suddenly?
Mystery 4. Why can't we forecast exact streets and exact minutes?
Mystery 5. Small local boundaries can decide everything, but they're hard to measure in real time.
These mysteries are why tornado research never stops.
Because every improvement becomes minutes of warning and lives saved.
After a tornado, the strongest force is people helping people. Recovery is slow, and it is real work.
Science continues. Better data, better forecasting, better communication.
The truth about tornadoes is not that they are supernatural.
It is that they are physics concentrated into a narrow, violent form.
Today, Union City sits inside that truth. A storm becomes history the moment it touches a town.
And the next mystery is already being measured. We live under an atmosphere that can sharpen into a blade. So we build knowledge, not fear. That is how you live with storms.
If you want more science that turns headlines into understanding, leave a like for Arcane Knowledge. And subscribe. Next time, we'll decode another mystery written in the sky.